Good morning, everyone. Welcome to another RebShort webinar. Today's webinar, we will be talking about the cPanel two-factor authentication bypass, and a link to a related article will be made available in the chat box. cPanel and Web Host Manager are two popular administrative tools for website administration. And these are published by a company named cPanel LLC. Now, according to the company, over 70 million websites are deployed that use their software for administration. One of the security features of the software is two-factor authentication during login that uses a mobile application such as Google Authenticator or Microsoft Authenticator or an app called Duo to provide that service. Recently, a flaw was discovered that allows attackers to guess the two-factor authentication token using a brute force attack. To better understand the attack, let's first take a step back and take a look at how two-factor authentication tokens are generated. The most common method that is implemented using the mobile applications that we talked about is an algorithm named the time-based one-time password algorithm. The process of authenticating a user takes place between a validator, in this case, the cPanel software, and an authenticator, in this case, the Google Authenticator mobile app, for instance. But before a user can be authenticated, the validator and the authenticator must share a secret value. Now, without this secret value, an attacker can't generate a valid one-time password targeted at this user. When the user activates two-factor authentication within the cPanel software, they either scan this QR code shown on the slide, or they manually enter the account and the key data that's listed there. And they put that into the Authenticator app on their mobile device. At that point, both the cPanel server software and the Authenticator app both have that secret value. Now, the algorithm, the TOTP algorithm, as the name implies, generates tokens based on the current time. So what happens is the app will take the secret value and combine that with the current time using the algorithm to generate the one-time password for the user. And as long as the server-side clock and the mobile device clock, as long as their times match closely enough, both devices will generate the same one-time password at any given time. Now, you might be asking that if the secret is combined with the current time, how often does the one-time password change? Is it every second, every minute? And that would be a really great question. The RFC document that describes how the TOTP algorithm works recommends that every one-time password that's generated be valid for at least 30 seconds. And this provides enough time for the user to interact with the smartphone app, read the one-time password, and type it into the login screen before the code changes again. Now, again, this means that each one-time password is valid for at least 30 seconds, but that's only part of the story. To account for clock differences between the validator and the authenticator, the RFC further recommends that the validator, which is the server-side software that validates that one-time password, it recommends that the validator accept one-time passwords from 2 time steps in the past and 1 time step in the future. This means that at any given time, 4 one-time passwords will be accepted by the validator, and each one will be valid for a maximum of 2 minutes. I kind of illustrated this here in this black and white diagram. If you take a look at it, at time t, which represents the current time, one-time password 0 is valid for the current time. However, the validator the cPanel software, if it follows the RFC, which most validators do, it should accept the other 3 one-time passwords represented here, one that would be valid at the current time plus 30 seconds, and 2 others that were valid 30 seconds ago, and another one that was valid 60 seconds ago. So this provides a 2-minute window of time that an attacker can try to guess any one code before it rotates out of this time window. Additionally, the one-time passwords are made up of just 6 digits, no letters, no special characters, meaning there are only 1 million possible values that any one code could be. So the 2 factors that we just discussed, the 2-minute time window and the 1 million possible values for a one-time password, those 2 factors are going to come together with an implementation flaw, excuse me, in the cPanel software to create the vulnerability. Now, after the user submits a valid username and password to log in, they see this screen, which asks for the security code. At that point, the user would go to the Authenticator app on their phone, read the code, type it into this screen, and click the Continue button. At that point, the value that they typed in is sent to the cPanel software on the server, and the one that it received is then checked against the one that it calculated for the current time. And if they match, the user is allowed to continue. If they don't match, the user is denied access. However, it was discovered that there is no limit to the number of times that a user can submit these one-time password guesses to the server. There was also no lockout mechanism after a number of invalid submissions. So that means with a little bit of programming knowledge, a program could be written that will send one-time password guesses at a high rate of speed, hoping that one of them will match one of the valid one-time passwords that the server will accept. Remember, those values are good for around 2 minutes, and at any one time, 4 one-time passwords will be accepted if they follow the RFC. And that's 2 minutes. That's really a long time when you're talking about using software to automate the process. And with only 1 million possible values for any one code, it wouldn't take very long to test all 1 million values using automation. More than 2 minutes, probably, but less than a day for sure. This vulnerability has officially been assigned CVE 2020-2764, and the issue is patched for versions of the software greater than the ones listed here on the slide. And throughout the presentation, I referenced cPanel, but keep in mind it also affects the secondary product, the web hosting manager, as well. One thing to keep in mind about this attack is that it does require an attacker to possess a valid set of login credentials, but with credential reuse and password stuffing attacks to discover those, it's not outside the realm of possibility. We recommend that if you're using cPanel as a self-hosted solution, please upgrade as soon as possible. The downside here is that a lot of these cPanel deployments are managed by web hosting providers themselves. If you host through a web hosting provider service, you typically don't have the capability to upgrade that software on your own. That will need to be done by the hosting provider. If you're unable to deploy the patch immediately, another possible mitigation, again, this will have to be done by the hosting provider if that's your situation. But another mitigation would be to deploy a rate limiting solution for the authentication endpoints. And this could be done using a reverse proxy such as Nginx or HA proxy. If you're not hosting your own deployment, then I think you're probably out of luck until the provider can upgrade the software. So it might be time to put some pressure on them to get it done. And that's all I have for today. I hope you enjoyed the material and found it useful. I'd like to thank you all for joining us. And if you have any questions regarding the topic briefed, please get in touch with Jay McKee at wapaclabs.com and join us again on December 9th for our next Red Short. Also, if you've missed any of our previous Red Short webinars, you can find them, you can find them at redskyalliance.org/redshorts. If you're not a member, you'll have to sign up, but our free membership will give you access to all types of Red Sky Alliance content. Have a great week, everyone.